Right now, sitting on a server that you can access for absolutely free is a piece of code. And this code literally outsmarts the most expensive, heavily guarded AI models ever built in Silicon Valley.
Yeah, which is just wild to think about. For years, the reigning assumption in the tech world was that true frontier artificial intelligence required this impenetrable corporate fortress.
Right, like you needed a billion-dollar data center, an army of engineers, and this massive moat of corporate secrecy. But sitting here in the current year, 2026, that entire premise has just completely collapsed.
It really has. Today, we are looking at a massive, undeniable disruption. 3 open-source Chinese models have officially leveled the global playing field.
Yeah, they've basically matched, and in some cases even surpassed, the proprietary giants. I mean, we're talking about OpenAI's GPT, Anthropic's Claude, Google's Gemini, and they are beating them in complex coding and advanced reasoning.
Exactly, and if you could see the backdrop behind me right now, I have this visualization of the global data landscape. For a long time, it was just a few massive glowing hubs in California.
Just a few concentrated monopolies.
Right, but now it's this sprawling web of shifting, interconnected nodes lighting up across the entire planet. Because what we are looking at today isn't just a story about software writing better code. It is fundamentally about the democratization of the infrastructure of human intelligence.
Okay, let's unpack this. Because if you are a developer, a founder, or, just someone trying to navigate this space, the scale of this shift is staggering.
Oh, absolutely.
We have hard benchmark data for this deep dive today, from Hugging Face, Artificial Analysis, LMSYS Arena, SWE Bench, and several independent academic reports. And they all confirm the gap is gone. But to understand how a decentralized open source community caught up to trillion-dollar tech monopolies, we have to start with the biggest bottleneck in AI.
Which is compute power. Scale has always been the primary hurdle. You cannot democratize a system if it requires a $100 million supercomputer just to turn the thing on.
Right, because the proprietary giants just threw brute force computing at the problem. They scaled up these massive monolithic models.
Exactly. So to compete, the open source community had to find an architectural breakthrough that made massive scale efficient. They had to figure out how to do way more with significantly less hardware.
Which brings us to Alibaba's Qwen 3, specifically the 235B-A22B model. And they use something called the mixture of experts architecture, right?
Yeah, mixture of experts, or MOE. And that alphabet soup of a name, 235B-A22B, actually tells you the whole story of how it works.
Right, so let's break that down for the listener. The 235B means the model has 235 billion total parameters. And parameters are basically the artificial synapses of the network, right? The connections holding all the knowledge.
Yeah, that's a good way to put it. But that A22B is the crucial part. It means only 22 billion of those parameters are activated during a single forward pass.
And a forward pass is just the technical term for the journey your prompt takes through the neural network to generate an answer.
Exactly. That selective activation is the core of the MOE architecture. Rather than a single massive brain where every single neuron fires for every single question, MOE divides the neural network into highly specialized subnetworks. They call them experts.
I think an analogy helps ground this. Imagine a massive research hospital, right? When a patient walks through the door, which represents your prompt, a highly trained triage nurse at the front desk immediately assesses the issue.
Right. They don't send you to every doctor in the building.
Exactly. If it's a heart problem, the nurse routes the patient straight to the cardiology wing. If it's a head injury, they go straight to neurology. The patient doesn't need to consult the podiatrist, the dermatologist, and the pediatrician all at once.
Yeah, and in Qwen 3, that triage nurse is a sophisticated router network. It analyzes your prompt and instantly routes it to the specific 22 billion parameters that are experts in that exact topic. It completely bypasses the other 200+ billion parameters across its 94 layers.
It's just so efficient.
It really is. What's fascinating here is how that precision impacts raw performance. By not forcing every parameter to compute every problem, Qwen 3 frees up massive computational overhead. It can focus deeply on logic and science.
And the numbers back that up.
Oh, completely. The MMLU Pro benchmark is this brutal graduate-level test covering everything from organic chemistry to advanced physics. Qwen 3 scores around 84% on that.
Wow.
And on the AM, which is the American Invitational Mathematics Examination used to find the best high school math prodigies, the model's thinking versions hit an astonishing 92%. It does that by routing its compute into step-by-step reasoning.
Okay, but wait, I need to push back on the practical application of this for a second. You're saying the open source community has this 235 billion parameter behemoth that you can deploy locally.
Yep, locally on your own hardware.
But my high-end laptop sounds like a jet engine taking off when I just open too many browser tabs. How on earth does a consumer machine even store 235 billion parameters, let alone run them, even if only a fraction are active at a time?
Well, that is the magic of the broader open source ecosystem working in tandem. You aren't just downloading raw, unoptimized code. The community has built these highly accessible deployment tools.
Like what kind of tools?
Frameworks like VLLM, Allama, and LM Studio. These tools use mathematical techniques like quantization.
Okay, quantization. What does that actually do?
It essentially compresses the precision of those parameters. It shrinks them from massive file sizes down to smaller, highly efficient formats without losing much accuracy. So when you combine quantization with the MoE architecture, a model that would have required a massive server farm 3 years ago can now run on a couple of standard consumer-grade GPUs under your desk.
That is just wild.
And for even lighter hardware, Qwen's smaller versions, like the 30 billion parameter one, offer incredible performance that you can run directly on a high-end laptop.
But, efficiency and routing tricks only solve the compute bottleneck.
Yeah.
Being fast and lightweight doesn't automatically mean you are smart.
Right, exactly.
So if Qwen 3 figured out how to run a massive model efficiently, we still have to look at the actual intelligence bottleneck. How do you train an open source model to outthink a proprietary giant?
And that requires looking at the second major model in this triad, which is DeepSeek R1. DeepSeek R1 represents a fundamental departure from how we traditionally build AI.
Because for years, the standard method was next token prediction, right?
Yes. You feed a model trillions of words from the internet, and it learns to probabilistically guess the next word in a sequence. And, it's highly effective, but it has a ceiling. It is fundamentally just mimicking human text, not generating novel logic.
So how did DeepSeek get past that ceiling?
They bypassed it by abandoning standard text prediction and utilizing large-scale reinforcement learning, or RL, using cold start data.
Okay, I want to clarify how different this is, because in a traditional setup, you have human engineers spending millions of dollars writing out step-by-step solutions to math problems so the AI can study them.
Right, heavily curated data.
But cold start data means giving the AI the absolute bare minimum, right? Just the basic axioms of logic and math and a scoring system, and then telling it to figure out the rest on its own.
Precisely. It's very similar to how the AI AlphaGo mastered the board game Go. It wasn't fed thousands of human games to memorize. It was given the rules of the board, and then it played millions of games against itself.
Just learning from its own wins and losses.
Exactly. And DeepSeek R1 did this for complex logic, math, and coding. It generated its own internal puzzles, attempted to solve them, and received a mathematical reward when it found the objectively correct answer. Over millions of iterations, it essentially taught itself how to think.
But doesn't reinforcement learning without human examples run the risk of generating complete gibberish?
Oh, absolutely.
Like if it's just trying to maximize a math score, couldn't the model just invent its own bizarre alien shorthand that no human developer could actually read or understand? How is an AI that thinks like an alien useful to us?
That was actually the massive technical hurdle the researchers faced. Left entirely to its own devices, an RL model will often find highly efficient but totally unreadable shortcuts.
So how did they fix it?
To prevent that alien logic, the DeepSeek team meticulously engineered the reward function. The AI wasn't just rewarded for getting the right answer, it was heavily penalized if it failed to output its internal process in a clear, readable, human language chain of thought.
So it forced the model to remain grounded in verifiable steps.
Exactly. And the model is fully open-sourced, including its distilled versions.
And the numbers validating this approach are just crazy. Yeah. Let's look at the Math 500 benchmark. This isn't basic algebra. This is a data set of elite competition-level math problems that regularly trip up human PhDs.
Yeah, they're incredibly difficult.
DeepSeek R1 hits a staggering 97% on this test. It is sitting right alongside, and in some metrics actually above, closed-source reasoning models like OpenAI's O1 and O3 Mini.
And in software engineering, it achieves a Codeforces ELO rating of around 2029.
Which, for anyone not on that site, Codeforces is a highly competitive platform for human programmers.
Right, and hitting an ELO of 2029 officially grants DeepSeek R1 candidate master status. That means under strict time constraints, it is outperforming a massive chunk of dedicated, professional human coders.
It also hits roughly 49% on SWE Bench. And for anyone not living in the developer trenches, SWE Bench doesn't just ask the AI to write a hello world script.
No, not at all.
It hands the AI a real complex bug pulled from a sprawling, thousands of lines long open source project on GitHub and asks it to find the problem and write a patch. Resolving almost half of those autonomously is mind-bending.
It really is. So we now have Qwen's localized efficiency, and we have DeepSeek's deep self-taught reasoning. But reasoning on a single puzzle in a vacuum is very different from maintaining a complex software project over several days or weeks.
Right, you need endurance.
Exactly. An elite model needs autonomy and memory, which brings the conversation to the next logical evolution.
Which brings us to the ultimate tool for software engineers right now, GLM-4.7, created by OscarAI. If DeepSeek is the brilliant mathematician solving the theorem on the chalkboard, GLM-4.7 is the senior developer managing the entire software lifecycle.
That's a perfect way to frame it. GLM 4.7 shifts the paradigm entirely toward agentic workflows. And an agentic workflow means the model isn't just chatting with you. It is actively using external tools, running terminal commands, testing code, reading error logs, and actually fixing its own mistakes.
And to do that effectively, it utilizes a massive context window of over 200,000 tokens.
Yeah, which is massive.
Just to quantify that for you listening, 200,000 tokens is roughly the equivalent of handing the AI 3 or 4 dense 300-page technical manuals and telling it to hold every single sentence in its working memory simultaneously.
Exactly.
Here's where it gets really interesting, though. Having a massive memory bank is totally useless if the model gets confused when retrieving the data.
Right, the needle in the haystack problem.
Yeah, anyone who has used an AI chatbot knows they suffer from context dilution. You give it a complex project, you chat back and forth for 3 hours, and suddenly it just completely forgets the strict parameters you established in your very first prompt. It just loses the thread.
Well, standard attention mechanisms break down over long contexts because every new word you type forces the AI to reevaluate every single previous word. It creates a massive amount of noise.
It just buries the original instructions under layers of casual conversational text.
Exactly. So to solve this, GLM 4.7 introduces an architectural feature called preserved thinking, along with interleaved thinking.
Okay, how does that work?
Instead of letting the core logic get buried in the noise of a long conversation, the model essentially creates a secondary, isolated track of memory. It caches the deep reasoning pathways and the foundational project rules in this secure scratch pad.
Oh, that makes sense. So while it generates new code and chats with you in the foreground, it is constantly referencing that pristine, preserved logic in the background.
Exactly. It fundamentally changes the user experience. GLM 4.7 acts less like a predictive text engine and more like a dedicated co-pilot or a junior developer who actually remembers the intricate project requirements you discussed 3 days ago.
And this translates directly to its performance on SWE Bench Verified, right? Where it resolves up to 73% of highly vetted, real-world software issues.
Yes. The developer community is also using it to dominate live code bench. That tests models on code that was published after their training data was collected, meaning it can't rely on memorized solutions. It has to actually think.
And people are using it for what they call vibe coding, too.
Oh, yeah, vibe coding is huge right now.
You give GLM 4.7 a purely aesthetic, high-level description of an application. Like you say, I want a dashboard that feels sleek, uses dark mode, and visualizes real-time server traffic. And it autonomously breaks down that qualitative vibe into the hundreds of low-level files, scripts, and API calls required to build it.
If we connect this to the bigger picture, the triad of Qwen 3, DeepSeek R1, and GLM 4.7 represents a tectonic shift in the foundational infrastructure of the internet. We are witnessing the end of the proprietary moat.
So what does this all mean? Let's lay out exactly what that economic shift looks like. Because for the past half-decade, the business model of Silicon Valley's AI sector was basically built on enclosure.
Right. Lock it all up.
You raise $10 billion, you buy a mountain of highly specialized chips, you train a frontier model, and then you charge the rest of the world a microtransaction every time they want to send a prompt through your API interface. You become the toll booth for intelligence.
But open source models offering radical transparency completely break that toll booth.
They really do.
When a startup founder or a university researcher or an enterprise IT department can download a model that matches GPT-4 or Claude 3.5 Sonnet for free, the barrier to entry drops to 0.
And they gain deep customization, too.
Absolutely. They can fine-tune the model on their own proprietary data without ever sending that sensitive information back to a third-party cloud. The operating costs plummet, and complete data privacy is guaranteed through local, on-premise deployment.
Now, obviously, there are challenges, right? Technical hurdles like hardware efficiency for smaller devs, handling cultural and multilingual biases, things like that.
Well, sure, alignment and security are still huge ongoing discussions.
But looking at the geopolitics of this, we really have to impartially lay out this global infrastructure shift. This forces us to ask a really difficult question about the future of tech monopolies. If these incredibly powerful open-weight reasoning engines are available for free and can run on relatively cheap hardware, how do the closed-source giants justify their massive server costs and API fees?
Well, they are being forced to pivot. The traditional closed-source giants are now competing against a decentralized, collaborative global community that is moving faster than any single corporate lab can manage.
The drawbridge is permanently down.
It really is. The strategic investment and open collaboration pouring out of the Chinese open source community has proven that massive centralized corporate structures are not the only way to drive frontier innovation. We are moving toward a highly diverse global tech landscape.
And that fundamentally rewires who controls the future of software. When you have multiple distinct ecosystems competing to offer the absolute best open-weight tools to the public, the ultimate winner is the end user.
Exactly. It fosters more accessible technology for everyone.
Whether you are building an educational app in Nairobi, a biotech startup in London, or an indie game in Tokyo, you now have completely unrestricted access to candidate master-level coding and reasoning capabilities.
And this rapid decentralization accelerates the pace of discovery across every scientific and economic domain. It allows hyper-specific industries to build custom agents that understand their exact domain logic without paying exorbitant licensing fees to a tech giant.
So taking all this in, 2026 is the year the open source community didn't just catch up to the frontier, they completely redefined where the frontier is.
They absolutely did.
We went from a reality where frontier AI was a black box locked behind a corporate paywall to a reality where it is sitting there waiting for you on GitHub. The efficiency is there with Qwen. The reasoning is there with DeepSeek. The autonomy is there with GLM.
The underlying architecture of innovation is now open for anyone willing to engage with it.
And we want to challenge you, the listener, to take advantage of this shift. The future of AI isn't locked up anymore. Don't just listen to the benchmarks. Go download one of these models.
Yeah, it's easier than ever.
Use accessible open source tools like VLLM or Llama to get Qwen's smaller models, or maybe a distilled version of DeepSeek R1 running locally on your own hardware. Test it out. Give it a complex logic puzzle, or ask it to draft a Python script. See what it actually feels like to have a brilliant reasoning engine sitting right on your hard drive, completely untethered from the cloud, and share your experiences.
This raises an important question, though, something for you to mull over long after this deep dive ends. We have just watched open source communities fundamentally disrupt the corporate monopolies on coding and reasoning.
Right.
Now, imagine the eventual arrival of true artificial general intelligence, a system that can outperform humans across every economically valuable task.
Which is the holy grail.
Exactly. If the first true AGI emerges not from a heavily guarded trillion-dollar corporate lab in Silicon Valley, but instead drops as an open source repo from a radically open, culturally distinct, and decentralized global network, how will that fundamentally rewire our digital ethics, our global economy, and our very definition of intelligence?
It's a staggering thought. For so long, the world assumed you needed an impenetrable fortress to build the future. But looking at the landscape today, it turns out the absolute most powerful thing you could do with a fortress is open the gates.